Let's explore how to best phrase a question so as to gain the best possible understanding of electrical concepts. The first step is to clearly define the specific area or topic that you are struggling with. For example, instead of asking a general question like explain electricity, focus on a particular aspect such as how does the GFCI outlet work, or what is the difference between series and parallel circuits. Secondly, provide context. Briefly explain what you already know about the topic and what you are finding confusing. This helps the person answering to tailor their explanation to your current level of knowledge. For instance, you could say, I understand that voltage is like electrical pressure, but I don't understand how it relates to current flow in a circuit. Thirdly, be specific about what you want to know. Avoid vague questions that are open to multiple interpretations. Instead, ask precise questions that target the specific point of confusion. For example, instead of asking what is grounding, ask what is the purpose of the grounding conductor in a residential electrical system and how does it protect against electrical shock. Fourthly, use technical terms correctly. If you are familiar with electrical terminology, use it accurately in your question. This demonstrates that you have a basic understanding of the subject and allows the person answering to communicate with you more effectively. If you are unsure about a term, define it or ask for clarification. Fifthly, break down complex questions into smaller, more manageable parts. If you are dealing with a complex topic, try to break it down into smaller, more specific questions. This will make it easier for the person answering to address each aspect of the topic in a clear and organized manner. For example, instead of asking explain how a motor works, ask what are the main components of an AC motor and how do they interact to produce rotation. Sixthly, provide examples. If possible, provide specific examples or scenarios to illustrate your question. This can help the person answering to understand the context of your question and provide a more relevant response. For instance, you could say, I'm trying to calculate the total resistance of a parallel circuit with 3 resistors, one at 10 ohms, one at 20 ohms, and one at 30 ohms. How do I apply the formula for parallel resistance in this case? Seventhly, ask about the underlying principles. Don't just focus on memorizing formulas or procedures. Try to understand the underlying principles and concepts that govern electrical phenomena. This will give you a deeper and more lasting understanding of the subject. For example, instead of just memorizing Ohm's law, try to understand why voltage, current, and resistance are related in the way that they are. Eighthly, ask for real-world applications. Understanding how electrical concepts are applied in real-world situations can make them more relevant and easier to grasp. Ask for examples of how the concepts you are learning are used in everyday devices, appliances, or systems. For instance, you could ask, how is the concept of electromagnetic induction used in transformers and generators? Ninthly, be patient and persistent. Learning about electricity can take time and effort. Don't get discouraged if you don't understand something right away. Be patient and persistent in your efforts, and don't be afraid to ask for clarification or further explanation. Tenthly, review and practice. After you have received an answer to your question, take the time to review the material and practice applying the concepts you have learned. This will help to reinforce your understanding and identify any remaining areas of confusion. Work through examples, solve problems, and try to explain the concepts to others. Let's consider some specific examples of electrical concepts and how to formulate questions about them. Firstly, Ohm's law. Ohm's law states the relationship between voltage, current, and resistance in an electrical circuit. To ask a question about Ohm's law, you could say, how does Ohm's law explain the relationship between voltage, current, and resistance? Or if I have a circuit with a 12-volt source and a 6 ohms resistor, how do I calculate the current flowing through the circuit using Ohm's law? Or if the current in a circuit is 2 amps and the resistance is 10 ohms, what is the voltage across the resistor? Secondly, series and parallel circuits. Series circuits have components connected in a single path, while parallel circuits have components connected in multiple paths. A question about series and parallel circuits could be, what is the difference between series and parallel circuits in terms of voltage, current, and resistance? Or how do I calculate the total resistance of a series circuit with multiple resistors? Or how do I calculate the total resistance of a parallel circuit with multiple resistors? Or in a series circuit, if one component fails, what happens to the rest of the circuit? Or in a parallel circuit, if one component fails, what happens to the rest of the circuit? Thirdly, grounding. Grounding is a safety measure that provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. A question about grounding could be, what is the purpose of grounding in an electrical system? Or how does grounding protect against electrical shock? Or what is the difference between grounding and bonding? Or what are the requirements for grounding electrodes in the National Electrical Code NEC? Fourthly, transformers. Transformers are devices that transfer electrical energy from one circuit to another through electromagnetic induction. They are used to step up or step down voltage levels. A question about transformers could be, how does a transformer work? Or what is the relationship between the number of turns in the primary and secondary windings of a transformer and the voltage ratio? Or what are the different types of transformers and what are their applications? Or what are the losses in a transformer and how do they affect its efficiency? Fifthly, motors. Electric motors convert electrical energy into mechanical energy. There are many different types of motors, each with its own characteristics and applications. A question about motors could be, how does an AC motor work? Or what are the main components of an AC motor? Or what is the difference between a synchronous motor and an induction motor? Or how does a DC motor work? Or what are the different types of DC motors and what are their applications? Or what is motor torque and how is it related to motor speed? Sixthly, generators. Generators convert mechanical energy into electrical energy. They are used to generate electricity in power plants and other applications. A question about generators could be, how does a generator work? Or what is the principle of electromagnetic induction in a generator? Or what are the main components of a generator? Or what is the difference between an AC generator and a DC generator? Or what are the different types of generators and what are their applications? Seventhly, electrical safety. Electrical safety is crucial to prevent electrical shocks, burns, and fires. A question about electrical safety could be, what are the basic principles of electrical safety? Or what are the common hazards associated with electricity? Or how can I prevent electrical shocks and burns? Or what are the safety requirements for working with electricity? Or what is the proper use of personal protective equipment, PPE, when working with electricity? Or what are the procedures for dealing with electrical emergencies? Eighthly, National Electrical Code NEC. The National Electrical Code NEC is a set of standards for the safe installation of electrical wiring and equipment. A question about the NEC could be, what is the National Electrical Code NEC? Or what is the purpose of the NEC? Or how is the NEC organized? Or what are the key requirements of the NEC for residential wiring? Or what are the key requirements of the NEC for commercial wiring? Or how often is the NEC updated? Ninthly, power factor. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. A question about power factor could be, what is power factor? Or how is power factor calculated? Or what are the causes of low power factor? Or how can power factor be improved? Or what are the benefits of improving power factor? Tenthly, three-phase power. Three-phase power is a type of alternating current AC power that is commonly used in industrial and commercial applications. It consists of three separate AC voltages that are offset by 120 degrees. A question about three-phase power could be, what is three-phase power? Or how does three-phase power differ from single-phase power? Or what are the advantages of three-phase power? Or how is three-phase power generated and distributed? Or what are the different types of three-phase connections? 11thly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. Question about overcurrent protection could be what is overcurrent protection, or what are the different types of overcurrent protection devices, or how do circuit breakers work, or how do fuses work, or how are circuit breakers and fuses rated, or how do I select the appropriate size circuit breaker or fuse for a given circuit. 12th, voltage drop. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. A question about voltage drop could be what is voltage drop, or what causes voltage drop, or how do I calculate voltage drop, or what are the factors that affect voltage drop, or what are the recommended limits for voltage drop in electrical circuits, or how can I reduce voltage drop in an electrical circuit. 13th, conductor sizing. Conductor sizing is the process of selecting the appropriate size of electrical conductor for a given application based on the current carrying capacity of the conductor and the allowable voltage drop. A question about conductor sizing could be how do I determine the appropriate size of conductor for a given circuit, or what factors do I need to consider when sizing conductors, or how do I use the NEC tables to determine the ampacity of conductors, or what is the difference between ampacity and current carrying capacity, or what are the requirements for conductor rating. 14th, electric fields and magnetic fields. Electric fields are created by electric charges, and magnetic fields are created by moving electric charges. Both electric and magnetic fields can have effects on living organisms. A question about electric and magnetic fields could be what are electric fields and magnetic fields, or how are electric fields and magnetic fields created, or what are the properties of electric fields and magnetic fields, or what are the potential health effects of exposure to electric and magnetic fields, or how can I reduce my exposure to electric and magnetic fields. 15th, renewable energy. Renewable energy sources, such as solar, wind, and hydropower, are becoming increasingly important as a way to reduce our reliance on fossil fuels. The question about renewable energy could be what are the different types of renewable energy sources, or how does solar power work, or how does wind power work, or how does hydropower work, or what are the advantages and disadvantages of renewable energy sources, or what are the challenges of integrating renewable energy sources into the electrical grid. 16th, smart grids. Smart grids are advanced electrical grids that use digital technology to improve efficiency, reliability, and security. A question about smart grids could be what is a smart grid, or what are the key features of a smart grid, or how does a smart grid improve efficiency, or how does a smart grid improve reliability, or how does a smart grid improve security, or what are the challenges of implementing smart grids. 17th, energy storage. Energy storage technologies, such as batteries and pumped hydro, are becoming increasingly important as a way to store energy from renewable sources and improve the stability of the electrical grid. A question about energy storage could be what are the different types of energy storage technologies, or how do batteries work, or how does pumped hydro work, or what are the advantages and disadvantages of different energy storage technologies, or how can energy storage be used to improve the stability of the electrical grid. 18th, power electronics. Power electronics is a field of electrical engineering that deals with the conversion and control of electrical power. Power electronic devices, such as inverters and converters, are used in a wide range of applications, including renewable energy systems, electric vehicles, and industrial motor drives. A question about power electronics could be what is power electronics, or what are the different types of power electronic devices, or how do inverters work, or how do converters work, or what are the applications of power electronics. 19th, electromagnetic compatibility (EMC). Electromagnetic compatibility (EMC) is the ability of electrical equipment to function properly in its electromagnetic environment without causing interference to other equipment. A question about EMC could be what is electromagnetic compatibility (EMC), or what are the sources of electromagnetic interference (EMI), or how can EMI be reduced, or what are the EMC standards for electrical equipment. 20th, arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can cause severe burns, injuries, and even death. A question about arc flash could be: what is arc flash? Or what causes arc flash? Or what are the hazards of arc flash? Or how can arc flash be prevented? Or what personal protective equipment (PPE) is required when working on electrical equipment that may be subject to arc flash? By following these suggestions, you can ask clear, specific, and informative questions that will help you gain a deeper understanding of electrical concepts. Remember to be patient, persistent, and always prioritize safety when working with electricity. Always consult with qualified professionals for any electrical work or when dealing with potentially hazardous situations.